so I will be gone. So, but you can come ask questions on Friday if you still have questions. Okay, negative exponents, we'll squeeze that in. Sometimes when you do the quotient rule division and you use the shortcut instead of expanding, you'll end up with negative exponents. So if we have like 27 pi, let's do 3 h to the third I to the fifth power divided by 9 h to the 8th I to the second. To use that shortcut when we divide, and we have to subtract. You run into negative exponents a lot. Are these guys exponents? No. So do we subtract them?
Yeah.
You follow what's between them, which is a fraction bar, which means divide. By fingers in the air, what is 27 divided by 9? Make sure we know this. Thank you. 3. So we divide that. Now with the h's, if we use the shortcut, remember it's top minus bottom. 3 minus 8. Like you read a book, top minus bottom. And then for the I, 5 minus 2. Okay, so 3 minus 8 is negative 5, correct? And I, 5 minus 2 is 3. Now, if you notice on the assignment you just turned in, the directions always said positive exponents only, which is why you couldn't leave the number 0 as an exponent. And it would either turn to a 1 or you'd erase it if there were other terms in the answer, because 0 is not positive, is it? No, it's neutral. So you couldn't leave your answer with negatives either. So this is how you fix it. Anything raised to negative power, does anyone know already how you fix? Oh, some of us already know. What's your name again? Braden. We're going to switch it somewhere. You were Andre, right? Yeah, by changing its location either up or down. So I'm going to move it down, which means I now have a fraction. It changes the sign of the exponent. And the 3 and the I cubed still, we're already positive. If I move them down, that'd make them negative. We don't want to do that. They're already positive. We're going to keep them positive. Okay, so this would be your final answer. Okay, so quick practice again. Does anyone have a 5-letter name in here? With all different letters. We have lots of 5-letter names. Okay, run back the bow. Yeah. What's your name? What was it? Jamie. Oh, but it's like spelled. Okay, spell your name for me. Oh, 2 I's. Okay, who else has a 5-letter name? But they all be different. Okay, we used you last time, so I'm going to go to your neighbor. Chris, I know how to spell that one. Okay. And Chris' favorite number? Thank you. Chris, what's your last name? So it starts with an H. Do you have a middle name?
Yeah.
What does your middle name start with?
H.
Oh man, that doesn't help. Okay. I was going to put Bob, but Bob also has 2 B's. Okay, Bo. Okay. So let's just practice what happens with negatives. Anything that has a negative, it's not just the -2 that moves. You notice how I circled it up above? The C is part of the raised to the -2 power. Those are glued together. Those have moved down. Anything else that needs to be moved down to make it positive? Yes. The I would move down. See anything else that needs to happen to make everything positive? Yeah, so you can also move up. So if it starts in the denominator and it's negative, to make it positive, you move it up. Same rules apply. Okay, so I'm going to write what's left. The b is going to move up, so b to the positive 9, h to the 8, r to the 4th, s to the 3rd. And the ones that move down, let's see, so it's no longer negative 2. Since we're moving its location, it's positive 2. The o to the 1st power, and I guess I in alphabetical order, right? I comes first, positive 6, and the o to the 1st power. That way everything's positive, so you can go both ways, up and down.
Does it matter if we do alphabetical order?
When I do the answers, they're usually written in alphabetical order, so it would help your neighbors mark them correctly if they were in alphabetical order. Okay, now we'll move on to our real lesson for today, unless there's a final question. Yeah?
Why did you
Because it was negative. Yeah, so you can go up and down to change the signs. Okay, so to our actual lesson on rational, exponents, and radicals. Does anyone know what a rational is? The word rational involves numbers. Rationals are fractions. Okay? Anything that can be written as a fraction, such as, well, repeating decimals, terminating decimals, those can be written as fractions. So what we're dealing with today is exponents, which are fractions. And does anyone know what a radical is? Radical? Rational? Do you know what a radical looks like? What does a radical look like? Kind of like a division sign, yep. There's something else that you should be familiar with that's like that division sign. That's a radical. Square root, exactly. That's the one you're most familiar with. A radical is that square root. Okay? Well, the square root is actually an exponent. Maybe you know this, maybe you didn't. So if I put I'll just put like an x in there. The square root of x is actually x to the, notice the word square. What number do we use for square? 2. So it's actually the rational exponent 1/2. We need a fraction, 1/2. Okay, so we have this thing called the index on radicals. The index is the number above the lip. I think this guy's called the radicand, but we're not really focusing on that, radicand. But the word we really need to know today is index. Sometimes it's not just the square root. Square root is the only one you don't have to write. Once we get into other roots, such as cube roots and fourth roots, you have to write those. So, square root of, say, 4 means what two numbers multiplied by itself, or what number multiplied by itself twice equals 4. Anyone know that? 2. And today we're just working with the positives, so 2. But sometimes the index changes. Sometimes the index changes to like a 3. Okay, so that would be called a cube root. Don't we usually use 3 for volume and we call it like feet cubed?
Yeah.
So cube root, the same word is used for cube root. What number times itself 3 times, and it has to be the same number. What number times itself 3 times is 8?
2.
Also 2. 2 times 2 is 4, times 2 is 8. Okay? Remember, these indexes are actually exponents. So this is the same as 4 to the 1/2 power. This is the same as 8 to the 1/3 power. Okay? So, for examples, we're going to practice finding the roots. The simplified form of the following. Example 5. Sometimes I'll give you it in radical form. Sometimes I'll give it to you in rational exponent form. So you have to know that they go both ways. let's do this. I'm going to give you 4 of them. Stand up when you have all of them solved. That means what number times itself 3 times is 27. I'm going to give you 4. Stand up when you have all of them solved. The index, you say, what number times itself this many times equals 27? Or what number times itself 5 times equals 32? What number times itself 3 times equals 64? And that's when you think you have all of them solved. Ah, careful on the last one. Especially your right. So what number times itself 6 times 27? These are generally small numbers, so your multiply can get really big really fast. So here's a hint, they're usually small numbers. Okay, yeah, that works, thank you. Okay, that's good. That's good. That one's good. Okay. And that one's good. Worried on that one? Okay. So this thing is a small number. Try to multiply it out 5 times, see what you come up with. Good. Huh? Yeah, yours is good. Those two, be careful with these to the right. Good. Same? Okay, let's rewrite it. Good, we're trying to get it there. Okay, everyone have a seat, please. Okay, fingers in the air. What did you get for A? What did you get for A? 3. Okay, let me expand this out and show you what's really happening. It's true that 3 times 3 is 27, right? So this index is saying you're looking for a group of 3. Remember square roots? You find that group and then you pull it out. Like square roots, you find a pair of 2. The index changes, you're looking for a group of that quantity. So that is 3. Fingers in the air, what did you get for B? This one's a little difficult because 32, but you have to multiply it 5 times. If you try big numbers, like 5 even, 5 gets big really fast, right? 5 times 5 is 25, times 5 is 125, times 5 is, I don't know, times 5 is something big. So this has to be a small number. Good. You should have 2. And what you're really doing is finding a group of common factors, factors, and get a 2. Fingers in the air, numbers, or letter C. 4. Good. 4 times 4 is 8, times 4 is 16. What?
4 times 4 is 16.
Oh, you're right. 4 times 4 is 16, times 4 is 64. Okay, and the last one, we're used to this one, right? We just have a 2 that we don't normally write. You don't have to write the 2 on square roots, but all the others, if the index changes, you have to write it. And 6, yes? Okay, good. I think you can do those. Let's try another set. The directions for this one are to write them. Example 6, Write each in, oh, I should probably show you the first one, and then I think you can do it. Write each in exponential, or each exponential expression in radical form. Write in radical form. Remember that word radical means, it should look like the square root thing. Oops. Okay, I'll help you with part A, and then I'll give you 2 to try. A is a to the raised to the 5/6. Okay, if you look up above on your notes, the square root, where did we place the 2 when I showed you the square root's equivalent in radical exponents? Where did the 2 go? Where? Well, it started in the index, and we wrote it as the fraction. Where was the 2? In the fraction, where's the 2 go? On the bottom, right? So, in this case, the denominator is always your index, 6. The numerator sticks around underneath. That's the denominator that gets booted, demoted outside the box. The denominator gets demoted outside the box. Okay? So, I will give you 2 to try, changing it into radical form. Change that one into radical form, please. And Edith, you're here, right? Hey, are you coming from the counseling center? Someone brought these 2 down, and they're not in this class. Oh, I know what she did. I'm 139. Maybe we go to 229. Okay, and the last one is, in parentheses, this is a challenge. Let's see if you can figure it out. Oh, that's a I should block that. Okay, try both of those. C is a little bit of a challenge. But still the same pattern. You're good? Okay, yeah, stand up when you think you're done so you can see how many you're done, and you can get a stretch break. You're really close. First one's right, and there's just one detail that you must not see, but I'm guessing a lot of people are going to miss that. Okay, that's a lot of people standing. Let's have a seat, see how we did. Ready, volunteer? Probably someone I haven't talked to yet today that can tell me B. B. No, there's lots of you out there I haven't talked to you. Remind me your name? Bryson. What did you get for B? Okay, yeah. So, actually, this brings a good point. Let's practice saying this. So we write, instead of square root, like we would normally say square root of x, we say cube root of x. Okay, so everyone say cube root of x.
Cube root of x.
And if you put the 1 here, is that okay?
Deb?
Yeah. You don't have to have the 1, but you totally can. Okay, now,
What is it called?
roots. R-O-O-T, like tree roots.
Okay.
Cube roots. Okay, now on C, let's see. Anyone think they have C? Okay, remember your name?
Sierra.
Sierra, yes. Okay.
So we distribute the seniors to 54 and 1.
Both can get it.
And then we put 3 in the index
So cube root of.
of 2,916.
Okay. Can you tell me the step before you did that?
Squared.
54 squared and. Okay, let me show you another really quick. These parentheses. Did anyone get to this point? Okay. Let me show you what just happened. Originally, was that squared supposed to be distributed, called like the power rule was to both? Does it belong to both because of the parentheses? So make sure you don't forget, because the way I've written it right here, only y has the squared. So either you need to put that in parentheses, or do what she just said, and distribute it. And distribute it to both. Both get the squared. Okay, so either you need to put parentheses or both get the squared. And 54 squared is actually able to be simplified into some big number. Tell me that number again. 2,916 y squared. Now, how many y's are here?
2.
2. Can I pull them out?
Yeah. Sure.
Look at your index. We can pull things out if they are in groups of
Oh, yeah.
3. So that's something you do need to check. Make sure sometimes you can pull it out. So let's be careful. But sometimes you can't. Let's try another one. I think we should try another one of those difficult ones. D. Oh, I'm so mean. This is mean. Okay. So it's good to practice once. Try it. And then check with your neighbors. See if you guys are thinking the same, getting the same. Feel free to discuss it with your neighbors as long as you're talking about the math problem. Okay, yep. And then something happens.
I got 729, A12, minus 3.
What's the first step? Now you keep going though.
So she's going to fix it.
Okay, that's the first step. It keeps going though. Okay. I think everyone at least has the first step. What's the index? Shout it out.
3.
3. Good. That denominator is the index. We get the cube root of. Make sure either you do it in parentheses or you distribute. The 4 needs to go to everything, right? 9 to the 4. A cubed to the 4th. B to the 4th. Now do you see why we did exponents last time? Because this has the power rule in it, and we need to know how to do that. If we have a double exponent, what do you do with those? Multiply. Okay, so we have 9 to the 4th, a to the 12th power, b to the 4th. Who's at least there? Okay, are we done? No.
No.
Okay, so do we grab our calculators and do 9 to the 4th power?
No.
No.
Take out the 8.
We're looking for groups of how many?
3.
3. So, let's see, I'll probably need to go down below. How many 9s are there?
4.
So that would be 9 times 9 times 9 times 9, yes?
Yes.
How many A's? Oh,
12.
okay. 1, 2, 3, 4. Some of you can do this in your head, but to demonstrate, I'm going to write them all out. 4, 5, 6, 7, 8, 9, 10, 11, 12. How many B's?
4.
Okay. We're looking for groups of 3. So guess what? I know some of you noticed that the A's are pulled out, but did anyone notice that the 9's pull out? So when you pull out a group of 3, what do you write in front? What number do you put in front of the cube root?
No.
Yeah, you pull out a 9. Because the cube root of, I think that's,
Oh.
okay? The cube root of whatever 9 cubed is, 9 to the 3rd power, 729 is 9. The cube root of 729 is 9. This right here, these three together, is 729.
Oh.
So, if you pull out a group of 3, it's just 9. So there's still a 9 underneath, though. Don't forget about that. How many groups of A's can I pull out? Groups of 3.
4.
I hear 3 and I hear 4.
4.
4 groups of 3, yeah? And so if I pull out 4 groups of 3, what do I write out front? I should scoot this 9 over. A to the 4. Excellent. And there are 4 groups. A to the 4, because we pulled out 4 groups. Okay? How many groups of B's can we create? Oh, no. So that's just B to the first. So we can only pull out 1. Were there any A's remaining? Any B's remaining? Yes. Oh, look at that. Did anyone get there all by themselves?
No.
Yeah. Okay, should we try another one? Yes. The pulling out. So whatever this index is, you're looking for groups of that many. All groups of 9, 3 9s. We have 3 9s, you can pull them out. 3 A's, 3 B's, you can pull them out.
That 3 was before the
Yeah. This tells you how many are going to be in each group. We're going to try another one. Maybe let's see if it becomes more clear. I guess I'm on E. Okay, try to keep the numbers a little smaller this time. Okay, so the quantity for AB squared to the 5/4 exponent. Okay, the 5/4 power. Work it out. You can work with your neighbor. You're missing 1 4. Actually, just look at your 4s again. Okay, started it. Either get it right or get further than we got last time. Let's see. Show me fingers in the air. What is the index? What's our grouping quantity we're looking for? Good, 4, that denominator. So we have the 4th root of, what do we do with this 5? Excellent, I like that word, distribute. Make sure you distribute it to everything. 4 to the 5th power, a to the 5th power, b squared to the 5th power. Can you tell me what to do next? Okay, multiply x, the double exponents, yeah? 2 times 5 is 10. Okay. How about in the red shirt right there? What's your name? Sean. What do we do next? We just multiplied our exponents. Now what should we do?
Find out how many groups can each one go into.
Okay. Before we circle the groups, don't we need to see them? So we should expand them.
Expand to 4, 5 4s, and 5 A's, and 10 B's.
Great. Like I said, especially when these numbers get large, some of you can do them in your head, others, yeah.
So we don't have to write it out.
Yeah, as long as you're getting it correct when you do it in your head. Some of you can do it in your head, but for make sure everyone's clear, I'm going to still expand it out. So we're looking for groups of 4 because of this number right here on the lip, that index. Okay, so Andres, how many groups can I make that have 4? And then I circle or box those guys. It pulls out to what number? Just 4. That whole group becomes the number 4 outside. So this one, we had a group of 9 times 9 times 9, which is actually the number 729. So because it's 9 times 9 times 9, the cube root we pulled out is just the number 9. Just like the square root of, 25? That's really 5 times 5, right? We have a pair of 5s, which pulls out, because the square root of 25 is 5. So this is confusing. So I want to make sure it's clear. When you pull it out, make sure it's just that number that was repeated, or the variable that was repeated, 4. Okay? How many groups of A's can I find?
1.
1. So do I pull out A, or just
A.
Just A. And there's only 1 of them. Okay, ladies in the back corner, back there, back row. How many groups of B's do I pull out? 2. Good. And there are groups of 4. So since 2 groups pull out,
B to the power 2.
excellent, B squared. I think that's it. Now that 4, now here's the problem people make sometimes. They put the 4 there and then put the square root out here. That 4 needs to be underneath the lip. Or above the lip, I guess is where it goes. Above the lip. Make sure that 2 is on the B and the 4 is on the lip. And then you write what's remaining. There is a 4 remaining. There is 1A remaining. And how many B's?
2.
B squared. That is the answer, which I saw a handful of you getting either close or were getting it. Any questions before we do the opposite way?
Sweet.
I'm going to give you now radicals, and you're going to change it into exponential. Reverse, okay? This is fun stuff. Oh, example 7, I guess I'm at. Write in radical exponential form. Rational, excuse me, rational exponential form. Okay. We'll start with okay, remember the index is what part of the fraction? Or the what?
Denominator.
Yeah, the denominator. So this 3 should become your denominator. That would be s. It's still squared, but the 3 becomes the denominator. Okay? So any exponents underneath here are the numerators.
What? Oh,
This is the numerator.
that's what happened that wrong.
Okay? Let me show you another one. Part B. 12 times the cube root of x to the 4th. Any brain soul think they can tell me the answer to this one? 12 times cube root of x to the 4th. The rational exponential form. What if the 12 wasn't here? Did you tell me that?
Yeah.
Okay, what would you say? In the back? I've forgotten. Jocelyn? Okay, Jocelyn. Okay, that's what it's called right now, but if we change it to exponential form, what would the exponent look like? X to the what? 4/3. The 3, that index is your denominator. And all we do with the 12, because the 12 has just been times. It doesn't have the power of 4, it doesn't have the power of 1/3, so it just goes in front.
Oh,
Yeah.
so
Okay, so let's see if I can give you a couple to try yourself. Oh, maybe I should show you one more. Because they get more complicated, so I want to make sure before I let you go that you know how to do these. How about, notice the parentheses are around everything underneath the radical. Is there an index written?
1.
There's not written, but it's assumed to be a square root, which is a 2. If it's not written, it's a 2. So you're looking for groups of 2. Now the one that's different this time is we have a bunch of stuff underneath with the 5. So all you do is keep that in parentheses. And what's the index? What's the denominator? 2. What do you think? Where do you think that 5 goes?
on top.
Top. Okay. This is square root. That's the only one we don't have to write. You can write the 2, but generally we don't write it. We just use square root. It's invisible. Yeah. After the 2, if you get any larger than 2, then we have to write 3, 4, 5. Okay, try this one. Oops, what happened there? C, D. 4 root of 256 a to the 8th. Now careful, this one's not exactly the same as C. Okay, so keep that in mind. Go ahead and try D. It's not identical to C. It's missing something that C has. If you think you have it, or if you get stuck, talk with your neighbor. Share with your neighbor. If you think you have it, share. If you need help, talk about it with your neighbor, see if they know what they're doing. Okay. Wrap up your conversations, please, in 3, 2, 1. You right there. What's your name?
Chris.
Chris. Two Chris's, huh? Someone else. Chris. Okay. Chris, can you tell me what you got, or maybe your neighbor got? Someone got?
I got 256, A, then 8 over 4.
A to the?
Yeah, 2 A.
8 over 4. Is the 8 to 4 only on the A, or is it also on the 256?
Just on the A.
Are there any parentheses? Okay. Notice, inside, the only guy with the exponent 8 is the 8, correct? It's not on the 256. Versus this one, everything was raised to the 5th power. And you put the 4 in the denominator, which is good for the index. I can see one more step to do, though. Your name? Brian. Oh, actually, I see 2 more things. Yes, I forgot about that one, too. 256 is under the root as well, right? So it also has the 1/4. And 8 divided by 4 is 2. We just need to simplify a little bit. 256 to the 1/4. A, that doesn't look like a 4, does it?
What? Wait, what's it now?
1/4 A squared.
I get one.
How did I get what? 1/4 because this 4 applies to both 256 and A.
And where did you get the 1?
Yeah?
So, I put it in parentheses, but kept the A to the 8 and then just raised it by 1/4.
Okay, so did you write 256 A the 8 raised to the 1/4?
Yeah. Is that right?
I would probably do half credit on that because it's not completely simplified. Okay? You see what he did? He grouped it in 256, which is actually the last example I'm going to do is a grouping one, too. Careful where your parentheses are. If it started with parentheses, I would keep it all the way in parentheses. Let's do one last example. E. I'm going to put it underneath C, even though E comes after D. This one right here I wanted to do. Third root of 125, all of that in parentheses, raised to the 4th power. Guess what? It's just the same thing as C. Even though all of it's in parentheses, it's the same thing as C. It would be 125 to the, what do you think? 4 thirds. 125 to the, well, just to show you can put parentheses in different places. But interior or exterior. However, yeah, thanks. Now we need to go get our books in the hallway. Okay, sometimes be careful. What is the cube root of 125 though? 5. Cube root of 125 is, well, 125 is 5 times 5 times 5. All of that raised to the 4th power. The reason I'm showing this, you can go to this, but then you still have work to do, because this would simplify. Because if the index is 3, we have a group with 3, so that pulls out to what number?
5.
5, which is raised to the 4th power, which is, I think I did this on the calculator earlier. Is that 725?
Yeah.
600 something? Does anyone have a calculator? 5 to the 4th power? 625? Okay, so it says simplify. Make sure, especially when there's numbers, make sure you actually simplify. Versus last time how I said leave it with the exponent. We're going to go all the way down. So this 125, first look and see, oh, can the stuff on the inside, is there anything that can pull out? Do that first. Simplify inside the parentheses first. Okay, we're going to go out to the hallway. and get your book, and we have to do the spec.